Hi everybody, this is Steve. This is another video in the series on how to create generative art. In this video, we're going to be looking at a bunch of different things that I couldn't fit into all the other videos and I just think are important. And the series is wrapping up, so I wanted to make sure I got these in. So the first thing I want to go over is there's a couple of ways to filter images. Let's start with a special effect called a drop shadow, which you see right here. This is some code I got from watching a video by Kazuki Umeda. This is his YouTube channel, and this is his video where he discusses the blur effect. The drop shadow makes a shadow, but this is not a p5 function. This is a function native to JavaScript, so it's going to look a little bit weird. drawingContext.filter equals, in quotes, drop shadow, and then the arguments are the offsetX in pixels, the offsetY, the shadowBlur, and the shadowColor. So if I make this, say, 50 pixels more to the right, you'll see this. And 50 pixels more down, or 40 pixels more down, you see this. And then the amount of shadow is this, so let's do 30. And you see that it's dispersed the shadow. Let's put it back to 15 and 15. And if I only have 20 pixels for the shadow, you can barely see it. If I have, say, 2 pixels for the shadow, then it looks pretty solid. And then, of course, I can change the shadow color if I want to something else. Here's a project of mine, Connected Circles, that does not have a drop shadow. Let me add the drop shadow now. And I think you'll see that it makes this pop a bit. Here's another project of mine with gradient art. Let me add the drop shadow, and here's a new piece with the drop shadow added, and you can see that it really makes things pop. The second thing to show you is a blur effect. There is a filter blur in p5.js, and that looks like this, and you would add that filter after doing the drawing. If I have this at 2, that's a small blur effect. If I put this up to 10, you'll see a very strong blur effect. However, that does take some system resources, so if you're having to do a whole bunch of blurs, it could take extra time. There is another blur effect that is native to JavaScript, and it works faster. This was demonstrated by Kazuki Umeda. So we'll uncomment that. So here that is. Now this circle is not blurred because there's a push here and a pop here, and the circle is after the pop. So if you put the blur effect within the push and the pop, then it only affects what is within the push and the pop. However, unfortunately, if you wanted a drop shadow and a blur, you can't do both, because if I add the drop shadow here, the blur goes away. So in this case, I would have to use the p5 blur. Now let's look at another native JavaScript filter, which is called hue-rotate. I'll bring that in, and you can see that the hue has changed. It has rotated the hue 180 degrees around the color wheel. If I only rotate it 10 degrees, then you'll see it's a lot closer to the blue that it started with. Another filter, this is one that's part of p5.js, is called Posterize. Now if I take that filter in, you're not going to see much of a change. But what if I blur first and then posterize? So we'll do that, and you get something like this. So what the posterize is doing is limiting the number of colors that are going to be shown. You see, if you blur, you actually are getting a lot of different colors here. But when you posterize, you reduce the number of colors that are being shown. Let's try a blur of 3 with the posterize, and you get this. A lower amount of posterizing is actually more posterizing, which is kind of weird. Let's do 2. If we did 255, then it's going to look the same as if we hadn't done anything. Now I want to look at something else that is native to JavaScript, which is a linear gradient. This is starting with white and gradually going to black. That's created with this function right here, create linear gradient. You give it an X and a Y start and an X and a Y end to the gradient. And you can add color stops. So right now it only has 2 color stops, but if I bring in this middle color stop, red, you'll get this, which is pretty interesting. If I were to move that color stop to 0.25, you get this, or 0.75, and you get this. So this is with a rectangle. We can do the same thing with a circle, although it looks kind of rotated on its edge, doesn't it? I don't know why it's doing that. Now you notice the CTX dot right here. Up above here is CTX equals canvas get context 2D, which is a mouthful. I'm going to leave a link to all of this code in the video description, and I'll also leave in the video description the syntax for all of these functions that I'm showing you right now. Besides the linear gradient, there is also a radial gradient. Let me bring that in, a rectangle. So this is creating a gradient around a center point, and then it goes out so that you get one color in the center and a different color out here. And this also has color stops. Let's get rid of this 0.8 color stop. We get this. Let's see what happens if we get rid of the green color stop. It's just all blue. And let's try putting the white color stop back. So another tool for your toolbox. This piece of code illustrates a number of examples I wanted to show you. So if I change the size of the canvas, notice that the picture changes with it. So the picture shrinks with the canvas. I've developed this tool for resizing your canvas. So I've created a large buffer canvas where I'm going to make my drawing, and then I'm going to scale that drawing so that it fits into the available space on my window. And it's a little complicated to explain, but there's this check ratio function that I created, which is looking at the aspect ratio of the image, comparing it to the aspect ratio of the available screen space, and doing some calculations to come up with a new width and height for your main canvas. And then I use a scale function so that when I place the buffer canvas onto my main canvas, the image of that buffer canvas gets scaled down. That way it will look the same no matter how big your canvas. Just remember, with the scale function, you always want to be scaling down, don't ever scale up, because then you'll get pixelation. So I'm just going to be giving you this tool that you can use. This also works for images. If you upload an image and you want that image to fit in the available screen space, then you would use this function. But there's another way that we can use the scale function. If we do this scale -1, 1, that is going to flip the image. So right now you see the blue rectangle is on this side, but if I uncomment out all of this, then the blue rectangle is on the other side. So what's happening here is I'm grabbing the image of the buffer canvas using get, and then I translate to the right side of the buffer canvas, and then I scale -1, 1, which is going to flip anything that's drawn after it, and that includes if you place an image. So I'm placing the image of the previous buffer canvas onto the buffer canvas. So that's how you flip an image. Link in the video description as usual. This function, window resized, is a special named function just like setup and draw. This will always be called if you change the size of the canvas, or the size of the window, I should say. And then this resize canvas function will resize your canvas to whatever width and height you want. Here's a new example that I might have shared with you before. This is calculating the time it takes for all the processes to happen in your program. So you can see down here I printed that this process took 0.11 seconds. This is the entire program right here. First we're grabbing the date.now, and I believe that's grabbing maybe the number of seconds in this millennium or something like that. Anyway, we're putting that into this start variable. And then I'm just running a for loop counting up to 1,000,000. Then at the end of that, I'm getting a new date.now minus the start. So what's the date now after we've done all of this, and compare that to what the date was before. So that's going to give us how many milliseconds have transpired. And then we're going to round that. And something I don't think I mentioned, when you use the round function, you can specify how many decimals you want to use. So I've got 2 decimals here, and I'm dividing those milliseconds by 1,000 in order to get the number of seconds. If your code is taking a long time to run, you can do this calculation in different sections of your code and then find out which part of your code is taking the longest. And then once you know which part of the code is taking the longest, then you can work on optimizing that part of your code. Now a new topic, the absolute function, which is ABS. If the number within the parentheses is a negative or a positive, it will transform that into a positive. The way I'm using that here is I have a main object that gets drawn either up here or over here or over here or over here, and then I want to find out if a second circle can be drawn. The question is, how close is it to the middle of the canvas? If it's close to the middle of the canvas, then I don't want a second circle drawn, but if it's way over here, then I could draw another circle over here. So I'm checking the distance between the first X and the middle of the canvas, but when I do that, I might get a positive number or I might get a negative number, so that's why I'm using the absolute of that number. Now I could have used a distance function, which is another function that I haven't gone over with you. So let me comment all of this out, and we'll do if dist of first X, comma, first Y, comma, width divided by 2, comma, height divided by 2. So we're getting the distance from one XY position to another XY position. And then I want to say, so if that distance is less than width times 0.2, then that means that there is a circle near the middle of the canvas. So that should work the same as it did before. So now you've got two new functions, the absolute function and the distance function. Another function that can be useful is this constraint function. So that's saying contain the number between this minimum and this maximum. So here I've calculated a number between 0 and 100, num1, which turned out to be 35.8, but I've constrained that between 40 and 60, and so num2 was only 40. If that random number is between 40 and 60, then I'm just going to get that number back. If the number is greater than 60, then I get 60 back. There's also a minimum function and a maximum function. We've already talked about the minimum function. I don't know if I mentioned the maximum function. So here I've gotten two random numbers. One is 64.2, the other is 1. The minimum of these two numbers is 1. The maximum of these two numbers is 64.2. Another function that might be handy is the random Gaussian function. This is giving you a random number with a standard deviation around a mean. So the mean is 0, which is right here, and this has a deviation of 30. If I decrease this deviation, you get this. If I increase the deviation, you get this. Let's put it back to this, and I can change the mean, increase it, and then decrease the mean, and I get this. But let's see what happens if we change some of these. I'm going to do 20 here, and we're going to do stroke of 0, 2, and then a deviation of 40. And then let's increase the number that we're getting here. So I'm going to do another for loop that goes j less than 25, I think, j plus plus. We'll do this and that, and now we get this. So we're getting some texture that starts here and gradually tapers off. I use random Gaussian in this example to make dark edges. It's drawing low alpha ellipses along the edge here, and it does more ellipses right near the edge, and as it goes farther away from the edge, it does fewer ellipses. This is using the clipping function, so there's actually more low alpha ellipses out here that you can't see. I talked about this process in this video on shadow edges. I'll leave a link to this video and also to that code in the video description. One last thing, only takes a couple of seconds. There is a shortcut for floor. You can use these two tildes. That is located next to your 1 button. It does the same thing as floor, and according to somebody on the internet, this process is faster than floor. That's all I have for you in this video. In the next video, I've got some parting advice for you and some resources I want to share with you. It'll be the last video in this series. I hope you've been making art. If you have, please post it on my Discord. I'd love to see what you're making. If you liked the video, give it a like, consider subscribing and ringing the bell for further notifications. Love to read your comments. Thanks for watching, and I'll see you in the next one. Bye!